Hi everyone, I hope you're well. So we're going to do turtle graphics, which is basically just programs that draw patterns. The logic of this you can use to make robots that would draw any patterns, and the application thereof would be something like a CNC machine or a laser cutter. And we're just going to go through the basics of turtle graphics. So first thing that they show us is how to make a normal square using turtle graphics. And you can see that if you use these basic turtle commands, forward, backward, left, right, pen up, pen down, it tells us in how many degrees it's going to turn to the left or how many degrees it's going to turn to the right, and then these are how many pixels it will move forward, backwards, and then you can raise the pen to draw in a smiley face or whatever you'd like to make. Okay, so they say open your preferred IDE, write, save, and run the square.py program shown in figure 1.8 and figure 1.9. Okay, so we're just going to recreate this, and I'm just going to open the idle. Okay, we go to the script, and first thing that we're going to do, just want to check what the name is, square.py, and we put this hashtag here as a comment just so that the computer will ignore whatever we typed in there. Okay, and since we need to import this from a library, it's the turtle library, we're going to import it from the turtle library from turtle import. Then we also have the import tkinter, and then we just start with forward and we say 100. So that's going to draw 100 pixels. If I were to save this, it's square.py, and I'm just going to save it under documents and square.py, say save. Okay, if I were to just draw this, you'll see that it's just going to make a single forward, and it starts here and it goes to the right. Now we need to say, okay, now you need to turn another 90 degrees and then go forward 100 pixels. So let's do that to it. So I'm just going to go here, and now I say turn right 90 degrees. Okay, this is cool. If you start typing in here, they actually tell you what it does. So, and then we just say forward, and if I say save and run the program, it went forward 100 pixels, it turned 90 degrees to the right, and then we're also telling it, okay, now you need to go 100 pixels forward again from there. And then we say right 90 degrees and then forward 100, and let's see what that does. Okay, so we've almost completed it, so we can say turn right 90 degrees, so then it's gonna, I wish I could show you my hand on the screen, but this line over here is going to turn like this, but it's not drawing anything, so we say turn 90 degrees and then complete the square. So we're gonna say right 90, whoops, and then forward. Okay, this should make a complete square. There we have it. Okay, quick tip, if you know that you're going to repeat something like this later on, we will start using for loops, and we're going to use something so that we don't have to do this. But for now, let's say you know you're going to do this a few times, then all you have to do is just say copy paste, copy paste, copy paste, and we don't need that last one over there, because we only need 1, 2, 3, 4 lines for a square, and you'll see that that still works. Okay, so for that specific activity, we have the code, which is square.py from turtle import tkinter, and we just paste it in there. Let's make it nice. There we go. And then the result. Where is our result? Come on, let's just run it again. Okay, we have the result right there. Okay, and the other thing is there is a challenge code where we have to make a triangle. So let's go to that here. Open your preferred IDE and write, save, and run a turtle program that draws an equilateral triangle. Okay, so triangle means that we're just going to have 3 lines. So if we were to just try and draw the lines, we're just going to have 3 lines like that. Okay, so that's all we need. But if we say turn right 90 degrees, it's not really a triangle. We need this angle over here to turn that side. So there's more than one way that you can do this. So very quickly we can just say make that 45. Oops, let's not make that 45, my bad. Let's say minus 45. Okay, wait, so if 90 degrees, let me just, sorry, I just have to figure this out quickly. So if we say, where is that point? Just quickly want to see it again. Okay, so there is the 90 from there. So from there to there is 90 degrees. So if we say this was straight and it's going to turn 90 degrees to the right, if we say 90 again, it's going to go back. So we need to say 90 plus 45. So 90 plus 45. And then, since it's a triangle, they said it needed to be equilateral. Okay, so we have the basic shape of the triangle now, so we know that this needs to be 135. But now we also need to think, okay, by how much should this angle over here be? It would be nice if we had a 90 degrees here, which just means this angle over here will be a bit longer. So if we, let's do this. If we use Pythagoras, we want 90 degrees over here. Right now we have 135 degrees over there, and this is 100. That is 100, and we actually want to know by how much should this angle from this 135 over here, by how much should that go there. So Pythagoras just says that this unknown angle over, this unknown side over here squared should equal to 100 square plus 100 square. So if we want to find out how many pixels we should make it go that side, then we can just get the square root of 100 squared plus 100 squared. Okay, so just to make it a bit quick, I'm just going to go take out the calculator, and we can just say 100 times 100 plus 10,000. Okay, and then we can just get the square root of that. So that 141.42, that's the value that we're going to use. So I'm going to say copy, and we're going to say put that in there. And if we run it, we have our perfect triangle. Okay, so problem is this is a right angle triangle, and you can see that the instruction actually told us write and run a turtle program that draws an equilateral triangle. So equilateral triangle. Okay, it just means that all the sides have the same length. So if we want to keep with 100, I'm just showing you that you can play around to try and figure things out. So let's say we just go back to the program. Okay, so I initially made a mistake. So I was thinking that it's going to turn 60 degrees, and it will change in the direction of 60 degrees. But the problem is that 60 degrees is basically the exterior angle. So what we have to do to make that interior angle 60 degrees, we just have to put in the exterior angle. So I'm just going to put in here 100 and then turn 120 degrees so that that interior angle is 60. Then turn 120 degrees so that this interior angle is 60, and then both of them would be, well, all three sides would be 100 pixels long. And yeah, that's all we had to do for the challenge task. So for that we can just put in the code. Just making it a bit smaller. And then for the result, I'm just going to press F5 again. Okay, the main reason why I want you guys to do this is so that whenever you think, oh, I want to do something in the, like, I remember doing something similar, and I forgot what the code is and also what the code did. Then you can go back to these PDF documents that you made and you can just see, okay, this is the code I made and this was the result. So it's just like a toolbox. Like, you know that your screwdriver is going to be used if you need to unscrew or screw something. So this will just help with that. So I'm just going to save this and save as, print PDF, and then square and triangle, and then we can just say save. So this is what you will upload on this assignment, and you are welcome to play around with this. It's actually a lot of fun, and then you can also just apply some geometry from math and yeah, basically make your own virtual CNC machine, virtual laser cutter. You can make this more advanced, but for now this is good. You can even have the user put in let's say input. We can ask the user how long should the length be of the triangle. How long should the length be of the triangle side? It's not a very good sentence. My bad. Input. Okay, and just say side length. Now instead of saying forward 100, we can actually put in the user input, so they can decide how many pixels should the triangle be. So we still want it to be an equilateral triangle, so we can even just say print. We are going to draw an equilateral equilateral triangle. So now this program is going to start as soon as we get the user input. So I just want to put there a colon. Okay, so what should the length be of the sides? Let's make it 300. And I say enter. Ew. Side length. Okay, let's make that integer. Because the user input is usually text type or a string. So let's make it 300. Now where is, oh, here it is. Okay, so I'm just going to close this and we just run it again so that you can see how it draws 500. Okay, it keeps on wanting to draw outside, But now you can see, so the user can give us an input, which is really cool. So yeah, I didn't check what the problem was here. Usually before I try to figure out what this is, I first go to my code and then I think, okay, what would have been wrong? And then I just remembered that any input from the user is of a string type. So it's a string. So the computer can't do any computations with a string unless you tell it, okay, change this string value. So A, B, C, D, E, F, G, it's basically like, this is how the computer would read any string, even though we know that we ask them to put in a number. You'll see if I have a user that's trying to be funny and they type in 9, you can code it so that this would work, but let's say they type in 9, you'll see that we'll also have problems because you can't do operations on letters. Like the computer reads that 9 as, so goes so many units forward, and the computer is like, no, we can't do that, that is not a number. But if the user actually put in a number like that, let's say they put in 22, okay, so this usually would work if we look at it, like go 22 pixels forward. The computer doesn't read it like that. It's still going to read it as a string because it's inside of these parentheses. So even if I type in 10 there, it's going to give us an error because it's still reading this as just a bunch of letters, something that cannot be computed. But if you have 22, that's the string, and we just tell it, okay, this is actually a number, so all it's going to do is just going to take the value inside and it's going to convert it into a integer or a float. Integers are just whole numbers, so this would be read as, I just want to show you that it works before I go on, so I'm just going to say 10. So our triangle is not going to look very good now, but that's our triangle. You can see that it worked. But the computer is going to read this, like it's seeing this, but it's going to read it. It's going to change that 22 string into 22 integer. So it's going to know to go so many pixels forward. Okay, so that's how it's going to read this instruction over here. Okay, I hope that helped. I know it was much more than they asked us, but it's good to just go through the program and just see how it works. If you have any questions, you can just WhatsApp me or ask me on the video. Enjoy the rest of your day. Bye.